Hey guys, this is a YouTube video going through our extra credit practice assignment so that we'll be ready to do one that comes out this weekend. So let's start with question 1. Which of the following best fills in the blank? An argument is a connected series of sentences, statements, or propositions called the blank that are intended to give reasons of some kind for a sentence, statement, or proposition called the conclusion. So in this case it is answer B. And I think one of the best ways to see a hint is that we see the word conclusion. And we know that an argument is a connected series of statements, sentences, statements, or propositions called the premises. They're intended to give reasons of some kind for a sentence, statement, or proposition called the conclusion. Putting in any of these other answers would not really seem to make as much sense. Reasons, we don't really have a term reasons. Conditionals is the if-then statement, so that doesn't really work. And conclusions, obviously, you don't go from conclusions to conclusions. Alright, question 2. Which of the following arguments appeals to ethos? So, before we evaluate these, let's just remind ourselves for a moment what ethos means. So, it means an appeal to authority. If you've ever heard someone say, oh, a person had a certain ethos about them, that's sort of one way to think about it. So when we go through these, let's see which ones talk about authority. So A. I took logic because logic gives you good reasoning skills, and I want to be a person with good reasoning skills. There's not really any mention of any authority, it's just I want to be good at logic because it gives me good reasoning skills. So B. I took logic because my dad says it's good for me. So clearly this is an appeal to an authority saying, oh, my dad says it's good for me. This is an authority figure saying that it is good for me. So that is the answer, but let's walk through the other ones just to make sure that we don't get it wrong. So C, I took logic because it is cool to take logic. This doesn't have any appeal to authority, it just says that it's cool. It's just my opinion that it's cool. D, I took logic because it's the only class that I could fit in this time slot. Obviously, this is just talking about the constraint of his class times, it doesn't have any mention of authority. So B is the correct answer. Okay, question 3. Which of the following arguments appeals to pathos? So similarly to the last question, let's remind ourselves of what pathos is. This is an appeal to emotion. So when you think of pathos, think emotion. So A, which of course is the correct answer, you should convict the suspect because the family of all the victims have suffered so much. Obviously this makes someone sort of empathize and imagine the sort of suffering that these people have felt. So it is an appeal to emotion, and it is the correct answer. Like in the other question, I'm going to go through the rest of these and just make sure we've got it right. So B, you should adopt a puppy because Beyonce adopts puppies. So there's not really any emotion here, it's an appeal to ethos actually, because we're saying, oh, Beyonce's this great figure, and she adopts puppies, so we should too. C, the evidence overwhelmingly implicates the suspect. This is not really a very emotional statement, it's just very straightforward and reasonable. And then D, you should convict the suspect because the prosecutor is one of the best in the business. Again, this doesn't really have any emotional appeals at all in it. So the correct answer is A. Alright, question 4, it's the last of these sort of questions. In our discussion of rhetoric, logos refers to what? So, in this case, I'm just going to tell you it's an appeal to reason. And the way to remember this is like, okay, it's an appeal to reason, it's an appeal to logic. So you can sort of tell from logos, the word logos, logic, they look and sound similar. So that's an easy way to remember that. So the answer is D, an appeal to reason. Okay, let's move on to the true or false questions. So number 5, true or false? The part after the then in a conditional is called the conclusion. So when we think of a conditional, that's the if-then statement. So if you remember from earlier in class, the actual terms for the if is the antecedent, and the then part is called the consequent. So this would be false. Number 6, true or false? Some arguments with true premises and a false conclusion are valid. So we sort of tried to clarify this in class, but it seems that what we came to was that this is false. Because we know that from the definition of validity, it cannot be an argument that if it has true premises, results in a false conclusion. So this is false. Number 7. True or false? The following is a valid argument. If it is raining, then Leah will get wet. So I think that the big issue with this question is that it isn't really an argument. It is a proposition, but if an argument has premises and a conclusion. This is just one statement saying that if it is raining, then Leah will get wet. True or false? In philosophy, we assign truth values to arguments. So in philosophy, arguments we speak about in terms of like validity, soundness, non-circular, connected premises and conclusions, etc. What we talk about in terms of truth values are like propositions and premises and conclusions. For example, all meat eaters are animals. That is something we would think of in terms of true or false. But if we're looking at an entire argument, we would say it's valid or invalid or sound, etc. So this is false. Question number 9. True or false? All sound arguments are valid. So if we think back to the definition of soundness of an argument, we know that the first part is that it is valid, and the second part is that its premises are true. So we can already tell just from the definition that a sound argument has to be valid. That's just part of its definition. So this would be true. True or false? If the antecedent is true and the consequent is false, then the conditional is false. So if you refer to the truth table of an if-then statement or the P horseshoe Q conditional, however you want to look at it, the only result that is false is when the antecedent is true and the consequent is false. So when P is true and Q is false. So this is true. Number 11. True or false? Some sound arguments have false conclusions. So this is false. Like I said earlier, the definition of soundness is that it is valid. Now that doesn't say anything about the conclusions yet, but it also says that the premises are true. So we know that the premises are true, which means that because it's valid, it can't have a false conclusion. So this is false. Number 12. True or false? The statement, "Frankie, open the door," is a proposition. So this is false. And that's because this isn't something that we can evaluate in terms of truth value. We can't say Frankie open the door is true. We can't say Frankie open the door is false. It isn't a proposition. A proposition is something that we evaluate in terms of truth value. So this is false. Number 13. An argument is blank if it is possible for the premises to be true and the conclusion to be false. A. Valid. So if you just look at the definition of validity, we know that this is not true, because validity says that it is impossible for the premises to be true and the conclusion to be false. So that is incorrect. B. False. So this doesn't make sense. We don't evaluate an argument in terms of true or false, so already if you say an argument is false, that doesn't make sense. C. Sound. So we know that soundness also means validity just because of its definition. So just like A, it doesn't work. So the answer is none of the above. And if you're actually curious about what it is, it's invalid, because it is the opposite of validity. Number 15. Use truth tables to test which of the following propositional forms are truth functionally equivalent to each other. So I know the term truth functionally equivalent sounds crazy, but I think the easiest way to remember it is that if we write it all out, are they the same? So let's start with number 1. Not P or Q. So in this case, we're only dealing with the variables P and Q, so those are the only ones we're going to write down initially. So if you look at this table, I've already filled out the true, true, false, false, true, false sort of split for P, variables P and Q. So what we're trying to find at the end is this. So let's start by filling out P or Q, and then we can just plug it into this. So if you remember how OR works, it is only false if both P and Q are false. So in this case, that isn't true. What I mean to say is that both of these are true, so they're not both false. So this is true. In this case, only one is false, one of them is true, so it is true. This is a similar case, and like I said earlier, if both of them are false, then it is going to be false. So in this case, not P or Q, all that we have to do is follow this not, which just flips the value from P or Q. So true flips to false, true flips to false, true flips to false, and false flips to true. Alright, number 2, not P or not Q. So the way we should look at this perhaps is that we want to break it up into pieces. So we know there's a not P piece, and we know there's a not Q piece, and we know there's a not P or Q piece, and then of course we know there's a piece that is not all of that. So in the table I'm about to show you, those columns will reflect that. So here we've got the not P, not Q, not P or not Q, and of course the final one that we're looking at. So not P, we know is just the opposite of P, so false, false, true, true, and similarly with Q, it's just the opposite of Q in its original column here. So false, true, false, true. So not P or not Q. So we're looking at these two, and we're going to be using OR with them. So like I said before, the only case where OR is going to result in false is when the parts on the either side of it are false. So in this case, that's right here. So that's going to be false. In every other case, it's going to be true. As long as there's one true part, you know that it's going to be true. So now, it's not of what we had here. So just simply flip it. So true, false, false, and false. Alright, number 3, not P and not Q. So, like I said before, we're going to look at it in pieces. Not P, not Q, we already have those in the table. But the next piece is going to be this not P and not Q. So, let me make another column for not P and not Q. So the thing to remember about AND is that in a way it's almost the opposite of OR, because in this case the only time that it's true is when both of these are true. The rest of the time it's false. So let's look at the first example. So false and false. So obviously there's at least one false, so we mark it as false. Next row, false and true. This one is false, and since there's at least one false, we mark it as false. True and false, just like the last one, there's at least one false, we mark it as false. And true and true. So there's not any false, they're both true, so we can mark it as true. Alright, and number 4, P and Q. So this is going to be similar to number 3, it's just that instead of not P and not Q, we're going to be doing P and Q. So let's look. P and Q. So if you remember from last time, it's just that if one of them is false, then as long as at least one of them is false, then the result is going to be false. So P and Q, true and true, that has to be true because they're both true. True and false, there's at least one false, so we have to mark it as false. False and true, same thing, there's at least one false of those two, so we have to mark it as false. And false, there's at least one false, in fact they're both false, so we still mark it as false. So if you remember, the sort of reason for doing this question was that we wanted to see which of the tables were the same to each other. So I've reorganized them like this, so we just have the ones that we made here. So let's look. This column seems to be the same as this. So we can say that 1 and 3 are functionally equivalent. And if we look again, this column is the same as this column, so we can say that 2 and 4 are also functionally equivalent to each other. So that would be the answer there. Alright, question 16. And this is valid or invalid. We're given some premises and conclusion, and we're asked to show a truth table to figure out if it's valid. So the first step that we should do is label our different pieces. So let's say W is the Hannah lives in Wisconsin, and U is going to be the part that says Hannah lives in the US. So now, knowing those two things, let's put this into an argument form. So if Hannah lives in Wisconsin, then Hannah lives in the US. So that's W horseshoe U, if W, then U, right? 2. Hannah lives in the US, so that's simply just U. 3. Therefore, and because we know the word therefore is there, there's a possibility that this is going to be the conclusion. Therefore, Hannah lives in Wisconsin, so that's simply just W. So it looks like this, and we've marked these as the premises, and this is the conclusion. So let's go to the truth table. So here it is, here's for W, here's for U, and here's the if W then U. You can just imagine that that's a horseshoe. So let's first mark which ones are the premises and which are the conclusions. So this is, let's see, this is the premise 1. Let's look, make sure that's right, that's correct. The next one is U, so we know that's the second premise, and we know that W is the conclusion. So let's put C there for conclusion. So now let's just fill out this section. So W horseshoe U. So we know that true, true is going to result in true. True to false is going to result in false. False to true will be true. And false to false will also be true. That's just the truth table for that. You can memorize it. You can find ways and examples in your head to memorize it, but that's just how it is. So in terms of validity, we know the definition is that if the premises are all true, the conclusion can't be false. So let's focus on places where both the premises are true. So here's one, these two. So in this case, the conclusion is false, so there's no problem. Okay, here's the next two, where the premises are both true, but in this case we see that the conclusion is false, so we can say that this argument is invalid. Alright, number 17. This is a similar question. So it has the same variables W and U, and so let's look at this, because I know the argument's a bit different. So if Hannah lives in Wisconsin, then Hannah lives in the US. So that's the same. It's W, then if W, then U. 2. Hannah lives in Wisconsin. So that's W. 3. Therefore, Hannah lives in the US. So that's therefore U, and that's going to be the conclusion. So, of course, we're going to have a similar truth table. False, false, or excuse me, true, true. Except here's the thing, now that these have been sort of switched a bit. So the first premise is if W then U, so that's still the first premise. The second premise now is W, and the conclusion is now U. So similarly, let's look at any of the 1 or 2 column that are both true and see if there's any column in the conclusion that's false. So here's one. These two premises are true, but the conclusion is also true, so it's fine. And in this case, there are actually none other where they're both true. So this argument is valid because there are none that have these both true, but the conclusion false. Okay, this is a categorical logic question. So let's walk through it and first define what the different categories are. So just from reading through it, I put that M is metals, H is hard, and G is gases. Now if you read through the question, those are the 3 that occur. So the argument goes like this. All metals are hard, so all M is H. No gases are metals, no G is M, therefore no gases are hard. Therefore no G is H. So let's go to the Venn diagram. So here's the Venn diagram I've made. It's just kind of what I can make work on my MacBook here, but it should serve this purpose just fine. So let's go back. All M is H. That is the first premise. So we need to represent that the only part of M that there is the part of M that is also H. That sounds kind of strange, but another way to say it is that there's no M that isn't H, since we're saying that all M is H. So this portion here is the part that where M is by itself. It's either, with G or by itself, but it's not H. So we want to shade that part out. Kind of get the picture. Don't really need to do anything too crazy. Okay. So the second part is no G is M. So similarly, we don't want to have any G that exists that isn't also a part of M. So here's the part where G and M meet, so we need to shade out everywhere that isn't that in G. So here we go. Yeah, looks just great. Okay. So now we need to think about the conclusion. Therefore, no G is H. So no G is H. So that means we can't have any part of G that is also H. And that's this part. So we shade that out. So let's compare these two to see if this is going to yield this result. So here, let's look at the G and H meeting point on this one. So it's these two circles here. So if we look, there actually is a part between G and H that is still not really discovered yet. So we can't really say whether or not all G is not H. So this is going to be invalid. Invalid. Alright, moving on to question 19. This is similar to the last one. So the variables that I found from this are C is cats, F is felines, and A is animals. And like I said before, if you just read through the argument, those are just the ones that you'll find. So here's the argument. All C is F, sum A is F, therefore sum A is C, like it shows here. So let's go to the Venn diagram. Alright, here's the Venn diagram. So let's look at the first premise. All C is F. So here's C and F. So if all C is F, that means there's no C that we want that is not F. So this little section right here is where either C is by itself or it's with A. So we need to erase that, or shade it in this case. Okay, so let's go on to our next premise. Sum A is F. Okay, so that means there has to be some A that is F. So A that is F is this portion right here because it's where they both meet. Now here's the thing. These sections are both open. This middle, very middle part, and this part here. So since we don't really know which part it's on, we need to put it on the line between those parts, the little star or mark that we want to put. So that's on this curved line right there. So here's the conclusion. Therefore, sum A is C. And so we know sum A is C is going to go in the middle because we're saying at least one A is part of C. So let's compare. Is this something that we can find from looking at this part? Well, let's look. Here is the portion between A and C, this middle part here. So even though this star could potentially go in this side and make this image, we don't necessarily know if it's going to be there because it sits on this line. And if it falls into this section, well then it's not in this middle part between A and C. So we have to call this argument invalid because we don't have enough information. Alright, moving on to the last question. Using the truth table technique outlined above, test the following arguments for validity. So we did this already, this is just more practice, but now we're going to have three variables often, so it's good to look at this example as well. So number one, not P or Q, P, therefore R. So like we did in the other case, we need to look at the different pieces that we need to put into our table. So obviously we're going to have P, Q, and R at the beginning, but now we need a P or Q, and we need a not P or Q. So let's look here. There's our original table out for those variables. So let's look at this. P or Q. So P or Q, there's at least one true, so that's true. P or Q, same thing, true. P or Q, there is a false, but only one of them, not both. There's still at least one true, so we can still mark that as true. Same here, same here, same here, because these are the same, just they're flipped. Now here, of course, they're both false, so that has to be false and false. Now for this column, this is just the opposite of this, so false, 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 true, and true. So we've got our table filled out. The next step is going to be to label the premises and conclusions. So premise 1, not P or Q, so that's premise 1, P, that's premise 2, and R, which is the conclusion. So if you remember, we want to look at where 1 and 2 are both true and make sure that the conclusion is not false. So let's find any here. There are actually none, but I think the problem that she's trying to get out here is that these don't necessarily follow from each other. So since they don't really follow from each other, let's just say that it's invalid. Alright, part 2. Not P and Q, Q, therefore not P. So the pieces we're going to be having this time are P, Q, of course, the P and Q part, the not P and Q part, and of course the not P part. So let's look here. So not P is just the opposite of P. So false, 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 true, 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 and true. So P and Q. So we're looking at these two. They're both true, so that's fine. This as well. So here, there's at least one that's false. Q is false in this case, so that's false. Similar case there. At least one of them is false here. It's P in this case, so it's still false. Again there. And in this case, they're both false, so yeah, of course it will be false. Now, not P and Q is of course just the opposite of P and Q. So false, false, true, 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 and the rest are all true. So now that the table's filled out, let's, like we did before, mark the premises and conclusions. Not P and Q, that's the first premise. So 1. Q, let's do 2. And of course the conclusion is not P. So let's look to where anywhere under 1 or 2, oops, this should be C, anywhere under 1 or 2 that are, when they're both true, if the conclusion is going to be false. Of course, that will make it invalid. So let's look here. Okay, here's one. So here's where 1 and 2 are true. Let's look at the conclusion to see if it's valid. So it's true, so that's fine. Let's move on to the next one here. That's also fine. And so it seems like that's it. So this argument is valid. Alright, number 3. So P and Q, therefore P or R and Q or R. So let's look at the pieces here. P and Q is a piece, P or R is a piece, Q or R is a piece, and then this whole statement is also another piece. So let's look at that. P and Q, that's our first piece. So we're looking at these two, true, true, one is false, so false, same there, same there, same there. Those are both false, so of course they'll be false too. So now we're looking at P or R, so we're looking at these two. So true, because there's at least one true, same there, there's at least one true, so still true. True again, even though this one's false, there is still a true here, so we still call it true. Same there. Now, since these are both false, that has to be false. There's no trues there. Here, there's a true and a false, so that's fine. It's true or false, I mean to say. Here is another one where it's false or false, and it's going to be false. Now we do a similar thing with Q or R, so this is true, 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 two there that are true, false, so that's false, true, true, true. Here again, there's 2 that are false, so we mark that as false. So now P or R and Q or R. So we're doing AND of these 2 columns. So remember that with AND, if one of them is false, then it's definitely false. So here, both of them are true, so that's true. Same there, same there. Here, one of them is false, so we mark it as false. That's true, of course. Same thing there, it's false, true, and of course false for those 2. Let's mark the premises and conclusions. P and Q. So that's premise 1, and the only premise, I think. And then P or R and Q or R. So that is the conclusion. So we need to find any case where the premise is true, but the conclusion is false. And if we can't find one, it's valid. If we do find one, it's invalid. So here's true, that's fine. True, true conclusion, that's fine. And that's it. So this is a valid argument. Okay, last question. Number 4. P or Q, therefore P and Q, or Q and R. So of course, our pieces are P or Q, another piece is P and R, another piece is Q and R, and then this big piece which is P and R or Q and R. So let's go fill those out. So P and Q, we're looking at these 2 columns. So both true, so that's true, 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 true. Their 2 is false, both of them are false, so that's false and false. P and R, so we're looking at these 2 columns now. True, true, there's at least one false there, so false, same, and the rest are all false because they all have at least one false. Q and R is a similar story. True there, false there, and true there. So now we're going to be using OR of these 2 columns. So there is true. This one is true, even though there's one false. There's at least one true, so it's true. This one's false, because they're both false. Same there. And this is true, false, false, and true. So again, let's mark the premise, which is P or Q. And the conclusion, which is this one. So again, let's look at all the places where the premises are true, and if we can find a conclusion that's false, then we know it's invalid. So true, true conclusion, fine, true, true conclusion, no problem. But here, true and a false conclusion. So we know that that is going to be invalid. We don't have to look at any more. You can if you want, but once we find one example where the premise is true and the conclusion can be false, we know it's invalid. Alright, thank you guys for taking the time to watch this. I hope this helps. If you have any questions, please email me, please ask me questions, and even outside of a homework assignment, if you guys need help, you always can ask me.